All right, here we go again. We got lesson 1.5. Pretty much review of what we've been doing with we're gonna add, subtract. You can see I'm gonna show you some neat things I can do here on the video, but you can see here we're gonna add and subtract two functions and graph. So something pretty simple. Everything we've already done in the first four sections where we're doing operations with the functions. And then, we've already done that, and then we're going to have to actually just put a graph on here, which is going to be another y equals mx plus b linear function. So let's zoom in on the first one here. I'm actually doing this a little different. I do this sometimes where I'll just pull up your assignment and just do a few problems from it in the video. That way we know we're covering all the stuff, and the graphs look nice and everything. So here we go. So watch this. Here we go. Go right in here. We'll zoom it in like that. All right. So here's the first problem. What we need to do first is we're going to take, they want us to add, we have two functions, h of t and g of t, and the first goal here is to add them together. So over the side, on the right here, I'm going to add those together. So that's negative t, oops, hold on. I'm using a different device to do this, so I'm getting used to the pen on it. But I just wrote it while I was paused. So this is the first function right here. And then it says to add g of t, which is 4t. And then, of course, we would just get 3t minus 5. So that is the new function that's adding the two together. And then we just got to graph that. So we're basically graphing, think of it like y equals 3t minus 5. It's a line. It's a line because it's a first power of the variable here of t or x or whatever it might be. And this is the y-intercept. This is going to be the slope right here. So we're going to go down 5 for the y-intercept. 1, 2, 3, 4, 5. So put a point right in there. And then from that spot, we're going to go up 3 over 1 for the slope. So we're going to go 1, 2, 3, 1. There's another point right there. Right? So we got y-intercept was negative 5. That's this point right here. And then since the slope is 3 over 1, since the slope is 3 over 1, then we're going up 3 over 1, put my new point there, and then it's a line, so we can just connect the dots. It's not going to look perfect, but it'll look like that, sort of, like a big old dot right there. All right, not my best work, but it hopefully gets the idea across. So moving along here, here's number 3 on the homework assignment. Almost the exact same thing, but it has a minus sign right here. So we need to kind of reiterate that idea. So I'm going to go a little slower here. It's going to be f of x minus g of x, which would be x minus 2. This time I'm going to really focus on the fact that I'm putting a parenthesis around these functions. It's x minus 2 minus 2x minus 5. So it says f of x minus g of x. This is f of x right there, and this is g of x right there, and I'm minusing them. Now the reason I put a parenthesis here, it really made a point to do that, is this minus in the middle is going to distribute to this parenthesis. It's minus this whole function 2x minus 5. So by putting the parenthesis around there, it reminds me that I need to distribute that negative in there. So my next step is going to be x minus 2 minus 2x plus 5. No more parentheses. The parenthesis that was on here really didn't do anything. I was just trying to make it consistent that I have a function minus a function. But since there's nothing in front here, we're not having any distributive properties or anything. So I just rewrote that and then took off the parentheses. This one I distributed negative 2x and then plus 5. Now we don't have any parentheses in here. Of course, then we just need to combine the like terms. So we have these two here that go together, and then we have the numbers that go together, the constants they call them. So 1x minus 2x is negative 1x, and then negative 2 plus 5 is plus 3. And there's basically our new function. It's, we normally, when all we had to do was subtract or add the functions, then we were just leaving, that was our answer. But now we have to graph it, so I want you to realize that it's really this new function, and so we could either call it y equals, we could call it, it's f of x minus g of x equals, or we could even call it some new, h of x or something. But just keeping it simple, it's basically we're graphing, so it's y equals. We're going to go up 3, put a point there for the y-intercept. And then for this one, we're going to have to go, so what we have here for the slope is we have negative 1 over 1. So we need to go down 1, but then we're still going to go right 1 from the y-intercept. So we go down 1, right 1. It'll look like this. Whenever your slope is a negative number, the line is going to be going down as you're going from left to right here. As you're moving this way, the line's going to be going down. So that'll help. Once you understand that, it'll help you remember that even though you're going down 1, negative, the denominator is still a positive number. It's not 2 negatives. So that's why I'm going down, which is considered a negative thing. But then I'm still doing a right, which is considered a positive thing. Negative, positive. You could even think of the negative being down here and the positive being up here, and you could go up 1 and then left 1. Same line. It's not going to change what's happening, all in all for the line. All right, next one. Let's zoom in on another one here. This is number 5 now from the homework. And a little bit different. I'm doing kind of a little bit of everything here for you. I'm kind of stealing a lot of your problems. You guys can do the ones in between as your homework. So this one, of course, what makes it different is now we're multiplying the functions, which we've done all this before. We've been doing all the add, subtract, multiply, and divide in the first 4 lessons. But now it's just that last step of, making a picture out of it, making a graph. So let's start again by multiplying f times g. So to do that, we're going to write 3t plus 3 times 3t minus 5. See how this time I did not put any kind of sign in between them. It's not plus or minus. It's just this thing times the other thing, because that symbol right over there, times. All right, whenever we multiply 2 binomials, two-term things together, we're going to FOIL. Or in other words, we're going to multiply this times this times this, and then this times this, and this times this. It's going to be every combination, all the multiplication. So pay close attention. It's going to be 9t squared, and then we're going to have negative 15t. I'll stop there for a second. That's 3t times 3t equals 9t squared. And then 3t times negative 5 is negative 15t. Now we're going to hit the 3 with the 3t and the negative 5. So that would be 9t and then minus 15. And then you'll notice that these two are the same type of term, so we're going to leave the 9t squared, and then we're going to have minus 6t, and then minus 15. So you can see here that these two things here combined to make that. Negative 15 and positive 9 makes negative 6. All right, so now here comes the newest thing in this lesson, because so far there really hasn't been too much going on. We now have to graph not a line. This is not a line anymore because of this second power here, this squared. The only time you get a line, a linear equation, you'll see that this would have been a line if you graphed it individually. This would have been a line if you graphed it individually. But when you multiply them together, you're getting a squared term now, which is no longer a line. Only first powers of variables like this create the lines, just like 3t. Squared, no longer a line, it's going to be a curve. And if you want a little secret, it's going to be a parabola or a U-shaped object. So one of the most important concepts in this class, and any algebra class really, is if you don't quite know, what this looks like or any tricks on how to graph something, you can always just make a table. So you do something like this, and you would just start by making up values for x. So, in this problem, you might make up, you wouldn't know where to start. So maybe you'd start with some, -2. This is kind of a standard thing. -2, -1, 0, 1, 2. Say you did something like that. Now there's some work to be done here. I mean, now you have to take these numbers and plug them in individually into these spots for t, and work out what the y value is. Speaking of that, this shouldn't be called x. This should be called t, right? I'm putting it's t values, not x. All right, so let's do that. So let's go. It's going to be 9 times -2 squared minus 6 times -2 minus 15. So this right here is going to be positive 4 times 9 is 36. So this is 36. And then plus 12, and then minus 15. So 36 plus 12 is going to be 48, and 48 minus 15 is 33. It's not pretty. In fact, we're not even going to really graph that one, right? But at least we know where it is. It's -2, 33, which is going to be, if we're going, this is 1, 2, we're just not going to go up there and graph way up there. But we wouldn't know that until we started, plotting points here. Let's do -1. Maybe that'll be a little more reasonable. So we get 9 times -1 squared minus 6 times -1 minus 15. That would be 9 plus 6 minus 15, which equals 0. I'd say that's a lot more reasonable. All right, so we now have a point. I'm going to go put that point right on there right now. It's right there. -1, 0. And then the actual number 0, I can just plug that in my head, right? Because all I'm doing really is I'm taking the 0 and plugging it in there and there. It's going to kill that all together. It's going to kill that all together. So you're just going to be left with -15 there. Easy. Probably why this ready-made graph went straight down to 15 here. 1, 2, 3. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 right there. I think I got that right. And then 1 shouldn't be too bad. You want to plug a 1 in there? I'm going to have to do some of these in my head. I'm running out of room, but you can just listen to my thoughts here. If I plug a 1 in here, we get 1. 1 times 9 is 9. 9 minus 6 times 1. So 9 minus 6 is 3. So this is all 3 now when I plug this 1 in here. And then 3 minus 15 is -12. And so 1 -12 is right here. And it looks like this point here is supposed to be 1 down here. I think I only counted to 14, not 15. Hold on. All right, all fixed. And then let's see how this next one. We're already pretty good here because we can see that we know it's a parabola. Any U-shaped object, I mean any squared equation is going to be a U-shaped parabola object. So it's pretty much going to look, you know, something like this. Our goal right now isn't to become experts on graphing these. It's just to be, which we're going to do that, but it's just to get an idea of multiplying two functions together where it turns out to be a squared equation and then plotting some points for it. So let's look. We're going to do one more point though, just to feel a little better about this. So 2. If I put a 2 in here, I get 4. 9 times 4 is 36. 36 minus 12 is 24. And 24 minus 15 is 9. So it's going to be a 9. All right, so we have the 2, 9. That would look, you know, that one's going to be off the graph again. This one will be at 2 and then up 9 somewhere. So we'll go ahead and just estimate something maybe up here. And then it's a parabola, it's squared, so we're just kind of going to try to do our best to make it look like a U shape. All squared equations like this in this format are always going to be U shapes or parabolas. Parabola. Let's do one more thing. This is obviously switching gears. You can already see that. We don't have the actual equations this time. We just have these two graphs. We have, on my video, we have a blue graph and a red graph. On your homework, you'll just have kind of a darker black graph and a lighter graph. Okay? And it says add the two functions. So this is a little weird idea, but let's see if you guys can follow this here. What we're doing is what we're gonna do is we're gonna start anywhere on this graph. So let's say we started, what I want to do is try to pick a spot. I'm gonna start on the left and slowly move this way as I'm doing this. And let's say we start, I'm looking for spots where this is a nice point here. It's right on the grid, like where the two lines cross, and then so is this one at that same X value. Like if I pick this spot, this looks nice here, but when I get to this one, it's in the halfway point. This would have been fine. See how it's in a nice spot, nice spot. So you'll see what's going on as I pick. I'm just going to start, let's say I pick here. This is the X value I'm picking. Whatever it is, doesn't even matter. 1, 2, 3, 4, 5, -6, okay? At that spot, the Y value right here for this blue function is 1, 2, 3, 4, 5. So this value right here is 5. At that same, and that's from, let's say, it's from there to there, right? At that same X value, the red function is actually from 0 here is -1. So this value here would be -1. This problem says add the two functions. So at this X value right here, this value is 5, this is the Y value, and the other Y value is -1. If I add those two numbers together, I get 4. So 4, let's do green. So 4 is going to be the new function. So right here. Right? And then we just keep doing this at different spots. You know, what spots doesn't really matter that much. I guess you want to probably pick some of the, like on this blue graph, you definitely want to do the key spots where it, you know, changes directions. Maybe where they cross would be nice. But you just kind of pick some spots, as many as you can without getting too impatient. So maybe the next one, I'll do a couple over right here. So this is 3 and this is 0. So the blue graph's Y value at this spot is 3. The red graph's Y value is 0. You're adding, so 3 plus 0 is 3. So the new graph, the green one, would still be at 3. which would be right there. Do it again. Let's pick, let's do this spot right here where they're the same, right? So this is, they're both 1. The blue graph is up 1. The red graph's up 1. 1 plus 1, 2. So this is going to be 2. If you're doing it right, you'll notice that there's going to be a pattern to all your new dots. See how they're all forming a new line, okay? Let's do another one. Let's go, I don't know, about the next 2 over right here. So this, on the red one, this is 2. This is -1. 2 plus, remember we're adding the 2 functions, right? So 2 for the red, -1 for the blue, 2 plus -1, 1. So we're going to add that same, at that x value where I just did 2 plus -1. When I add those together, I get +1, which is right here. So along that same x value, this number plus this number, whatever that is the new number that I'm going to put right there. So I guess I'm going to go like this, 1. Let's definitely do the spot where this changes directions. So like right here, this is 3, and this is -3. So the red graph goes up 3, the blue graph goes -3, down 3. 3 plus -3 is 0. So the green graph is going to be at 0. And let's go over a couple more. Let's go to here. This is 1, 2, 3, 4. So the red graph's 4, the blue graph's -1, and 4 plus -1 is +3. So that means at this location, it's going to be up 3. And you'll notice that when this graph started to change directions, so did this new graph that we're creating change directions also. And we should do one more just to make sure everything's, now that it was going like this, and now it's actually getting steeper here. It should still fall in line. It shouldn't be some crazy, the thing's not going to come over here, anything. It should now come up and do something like this. So let's do one more. The red graph is 1, 2, 3, 4, 5. This length is 5. The blue graph is 1. And we're adding, so it's +5 plus +1 is +6, which would be up here. Everything makes sense because that's where it should be, because it's looking like this. All right, I think the video is long enough as it is. Some technical difficulties today. Apologize for that. I'm using a new machine to do it. I'm learning some stuff on it. I don't have my mic hooked up. You can probably tell that too. Still got to work that out. But I want to get you guys something to get going here. Expect some higher quality stuff moving forward. Maybe even extra high quality, because I am using a different laptop to do this. All right, so you should be able to get through some of those other homework problems. Make sure you go look at the PDF file. You can pull that up and then refer to this video, because the problems I did are exactly from the homework. Shouldn't have too many surprises. Work hard, be nice. See you soon.